Hello, my name is Max Thornton and I'll be giving you a brief presentation on problem solving. Problem solving is a mathematical skill that has become a focal point within the 21st century maths classroom. Problem solving aids students in building and strengthening their higher order critical thinking skills, skills that are not only essential to success within the three strands of the mathematical curriculum, but are utilised within all areas of the curriculum and beyond. Today's problem solving lesson will be targeted at the Year 4 age range and it will explore the lighthouse problem, which is available to you within the appendices, along with detailed descriptions of each of the content descriptors mentioned. I chose this problem as an example as it presents a non-routine problem where the solutions and methods are not immediately obvious. To assist us in exploring this problem, we'll be using Poly's 4-stage model as a guide, with the stages of understand the problem, devise a plan, carry out the plan, and look back and revise. Our first step when answering part A is to build an understanding of the problem. When working with worded problems, it is beneficial to highlight or rewrite the key elements of the question, starting first with finding out what the question is asking. When will the lights first be off together? And then compiling the known information, such as A is on for 3 seconds and then off for 3 seconds, and so on. Our next step is to devise a plan. Rees highlights that no matter the problem, children who are effective problem solvers plan ahead when they are given the problem. Whether held as a modelled or individual class activity, the planning process presents an opportunity to increase engagement, motivation and critical thinking by encouraging participation and collaboration from students. To solve this problem, I have planned to use a visual diagram in the form of a number line, a method which Angularly believes to enhance comprehension and understanding. The next stage is to carry out the plan. Starting from 0, we have a number line extending. We should then follow in rows, colouring in the patterns presented by each lighthouse. On for 3, off for 3, and so on. It can be beneficial here to stress to students that these drawings or graphs are used as a tool for problem solving and do not need to be artistic or detailed. From this diagram, it becomes obvious that the point when all the lighthouses are first off together is when C first finishes its on cycle after 5 seconds. Moving on to part B, we again need to establish an understanding of the problem. We need to find what the question is asking, the next time the lights come on at the same moment, and compile our information. For this, it can be beneficial to revise the solution and methods we used in part A, highlighting that while Poly's method is an accepted and highly utilised model for problem solving, this should be used in a flexible nature, where steps can be interchanged or omitted where needed. Looking at the diagram, we can identify where each light turns on and identify the multiple of pattern that this presents, 6, 12, 18. Adhering to content descriptor ACMN A074, investigate number sequences involving multiples. Once we have established these 3 points of 6, 8 and 10 that the cycles represent, we can use the method to find a common multiple as an estimate by timesing each of these together. 6 by 8 by 10 is one common multiple of 480. This number shows us that while this method is good for part A, it may not be appropriate for part B, as to continue this pattern out to 480 in this scale, it will go around this classroom completely. After further collaborative brainstorming with students, it could be recommended to use a table as a tool to help with the problem process for part B. This enables inclusion of content descriptors ACMN SP096, construct suitable data displays, and ACMN A081, explore and describe number patterns resulting from performing multiplication, as we discovered earlier. While the use of calculators is often endorsed in mathematical problem solving, mental calculation is encouraged here, as it not only strengthens students' appliance to ACMN A075, recall multiplication facts, but can be used to demonstrate an example of where mental calculations are quicker than the use of a calculator. As students carry out the plan, scaffolding practices can be used to encourage thought about mathematical techniques that can aid and simplify the problem-solving process. Some possibilities are to encourage to calculate C first, which is an easier process for students, but also highlights a commonality between the answers. Each solution ends with a 0. This can be used to simplify the process for the remainder. As students are only looking for zeros, they can complete the table only where zeros are present, making it easier to find our solution of 120, a common factor, the lowest common multiple that we have found. It is important here, however, to use scaffolding appropriately, as too much scaffolding eliminates challenge and learning potential, while too little can leave students stuck, which can create a disassociation and demotivation towards mathematics. After this exercise, after they complete the exercise, it should be encouraged that students share their mathematical techniques and the processes, as this highlights the most effective manner to solve the problem and aids students to deepen their mathematical understanding. This is a concept that Rees identifies as one of the best ways at creating better problem solvers. Further reflective practices should then be utilised to check our answers. It can be beneficial to first pair our answers with the questions to make sure that the answers provided seem reasonable. Then we can explore our answers further. By comparing 120 against the common multiple, we can see it's easily divisible by 4, further suggesting that our answer is correct. We can also revise our solution by dividing 120 by each of the cycles found earlier, justifying our mathematical working earlier. As you can see here, 120 is easily divisible by 10, 8 and 6, thus suggesting our solution is correct. Thank you for listening and have a good day.